Hi, my name is John, and I will be helping or assisting Mr. Power's class with calculus, if he allows me. Anyways, I have 2.2 problem set done. So I'm going to share, let me share my information with you, okay? So where's my share screen? There it is, right there. All right, it's on the wrong side. I have two screens right now, so I'm actually going from my laptop to my big screen right here. Anyways, so I'll be doing 2.2 as part of the homework. I'll be doing 2.3 in a separate video. And by the way, it's from this calculus. It's called Stewart 6E. I have like 2 or 3 copies of this book. Definitely get this book. It has a lot of good stuff. You should have gotten it from Ventura Unified School District, and Ventura Unified uses this book for the past, I don't know, 20 years or something like that, 15 years, whatever. So let's look at this problem right over here. I'm going to make this a little bit bigger so that you can see it. Okay, that should be good enough. For the function r, here's your function below. State the following. Now, for number 8, get rid of this guy. I like old school, a whiteboard. So let's look at my whiteboard a little bit. Make it as big as possible. That's the biggest you can go, okay? So, what's the limit? Limit as x approaches 2. Not the limit of x approaches 2. You're supposed to say limit as x approaches 2 of the function r of x, right? Because there's no sign in the back right here, that means that it has to be from both directions. The limit as x approaches 2 from the left, that's from the left or from the negative side, must approach the same limit as x approaches 2 from the right or from the positive side of this function. Well, we know that, sorry about the sign right there, not the sign, sorry, what's it called? Reflection of the light. So the limit as x approaches 2 right here, approaching 2 from the left, this is your x, right? As it approaches 2 from the left, my function, my output is going towards negative infinity right here. So that's going towards negative infinity. And from the right, as x approaches 2 from the right, my function is going towards negative infinity as well. Since they have the same value, that means the answer is going to be negative infinity. Let's look at part B. What's the limit as x approaches 5? That means from both directions, because there's no plus or minus right here on the end. So from the left, it must approach positive infinity. As it approaches from the right, it approaches positive infinity. So this answer is positive infinity. Part C. I like to also have all of my students box their answers so they know where their answers are located. Okay. Part 3. This is a little bit more tricky, so let's work this out. The limit as x approaches negative 3 from the left side of r of x, right? So it's approaching, x is approaching negative 3 from the left side. That minus means from the left. From the left, as it approaches negative 3, my function r of x, my output is going towards negative infinity. What about D? What's my limit as x approaches negative 3 from the right? Okay, so as it approaches negative 3 from the right, not to the right, from the right, it's going towards positive infinity. So part D is going to be positive infinity. Oh, by the way, let's do a little bit something. What's the limit as x approaches negative 3 then? Let me move this up a little bit. Limit as x approaches -3, that means from both sides, it's going to be d and e, because it does not exist. I'm sure Mr. Towers will say d and e as well. So this is TLA, or three-letter acronym, means does not exist, because it has to have both the same values here. Part E, what is the equation of the VA? I like to use acronyms as much as possible because they're easier to write. And you should know these acronyms anyway. It's another TLA. This time it's two-letter acronym. So VA is Veterans Administration. I'm sorry, wrong VA. It's vertical asymptote, right? So there's a vertical asymptote here, another one here, and another one here, right? It's going towards positive or negative infinity. It has to be approaching, the function has to be approaching plus or minus infinity. What's the equation of this line? For number E, it's going to be x equals -3. If you do not put x equals, the College Board will count it wrong. So put x equals -3, x equals 2, and x equals 5. That's your VA. Or vertical asymptote. My P is not silent. Anyways, so there it is for number 8. By the way, it's about 3:43 a.m. I woke up a little bit early this morning. It's September 17th. Just writing it down for you. 9/17, 3:43 a.m. I couldn't sleep last night, so that's the reason why I decided to work on these problems for you guys. Anyways, so let's get another one right here. 13th through 16th, sketch the graph of an example of the function. I'm just going to do every single piece separately, and then you can put them all together. This is a little bit difficult. So 14, the limit as x approaches 0 from the left of the function f of x is equal to 1. So here's my xy axis. It's approaching 0. My function, my output is going to turn out to be 1 from the left. So it's going to go approach 1 this way. Okay, something like that. The second one, the limit as x approaches 0 from the positive, from the right of this function is equal to -1. So how will we graph that one? As it approaches 0 from the right this way, my y value is going to be -1. So I could draw it this way. You could draw it this way or this way. It doesn't really matter. I just like to draw it this way. Okay? So you can get rid of some of these. Let's look at the third one. The limit as x approaches 2 from the left of the function is equal to 0. Okay, so that means as x approaches 2 from the left of this function, I should approach 0. So as x approaches 2, there it is right there, from the left. So it's going to be something like this. Okay. Let's do the next one. The limit as x approaches 2 from the right of the function is equal to 1. So as x approaches 2 from the right, from this way, from the right, my y value is approaching 1. So it might go something like this. Okay. And f of 2 equals 1. This means my input equals 2, my output equals 1. My input is here, my output is here. Or in coordinate form, it's going to be input, output, 2, 1. And in fact, since there was an open hole here, it becomes a closed hole right here like this. That's what that says. It says f of 0 is undefined. Let's do the last one. What does this mean? F of 0 is undefined. F of 0 is undefined. That means there's no, when my input is 0, my y value does not exist. It could be a nothing there, or it could be a vertical asymptote. Okay, so you want to put all of these together for these steps. First step, second step, third step, fourth step, fifth, and sixth step. I'm going to put all of these for you together in one graph, okay, to see what it looks like. I'm going to do it like a symphony, like putting it all together in one shot, if possible. The first one says 0 approaches 1. It looks like something like this. Approaches 0 from the right, it approaches -1, something like that. Approaches 2 from the left, and my y value is 0. So that's 2 right there. My y value is 0. So I'm going to connect the dots here. 2 from the right, my y value is 1. My output is 1. So something like that. F of 2 equals 1. At x equals 2, my y value is 1. I'm going to plug up that hole. And F of 0 is undefined. So we don't know what it looks like. Okay, and that's your answer for number 14. Something like this. Like I said, it could be, function could be like this. The function could look like this. Do whatever you want. Okay. Let's do number 25. Next question. This is algebraic in nature. Please remember that 70% of your errors is going to be algebraic in nature. So make sure you guys get your algebra down. All right, 25. The limit as x approaches -3 from the right of x plus 2 over x plus 3. You can graph it if you want. That might be a best idea. I don't have my graphing paper. I'm gonna put values in here. It approaches -3 from the right. Here's -3, right? From the right, it's gonna be like -2.99. So I'm gonna put negative 2.999. It's gonna get very, very close to -3 plus 2 over -2.999 plus 3. Well, I get here -4.999. I'm sorry, -2.999 plus 2 is going to be -0.999 over, what happens when you get here? With -2.999 plus 3, it's going to be positive 0.00001. 1, 2, 3, 1, 2, 3. Oh, there's only 3 zeros. Okay, whatever. Close enough. When you divide by a very, very small number, the fraction becomes large. In fact, since it's negative divided by positive, you're going to end up with negative. And a number divided by a very small number here, it's going to be a very large number. Here's a very large number. That's your answer right there. Okay. You can use your calculator if you want to find your limit. Okay. Next question, 20. I don't know if I want to do 27 or not. Yeah, let's do 27. Okay. What's the limit as x approaches 1 of 2 minus x over 1 minus x quantity squared? That means because there's no sign here on the right hand side, that means it must approach from the left and from the right. And you have to find both limits. Limit as x approaches 1 from the right, let's plug in some numbers. Since it's approaching from the right 1, it could be like 1.0001. 2 minus 1.0001 all over 1 minus 1.0001 quantity squared. Well, this one, 2 minus 1.0001, happens to be positive 0.9999, I believe. Something like that. It's a number. 1 minus 0.0001 is negative 0.0001. When you square that, it becomes a positive, very small number. Positive, by the way, because negative squared is always going to be positive. So what's positive number divided by very, very small positive number close to 0? Number divided by very small number close to 0, approximately 0, is going to be a very large number. Okay? Which is approaching positive infinity. 29. The same process for all of these. You can use your calculator for number 29 to get your value if you want. You can plug in, since it's approaching 3 for the positive, you can try plug in 3.000001. You square that, minus 9. It's going to be 3 squared is 9, right? So if you can plug in 3, the natural log of 0 is negative infinity. So it's not, you can't do that on your calculator. So you have to plug in a number like 3.0001 in here, square it, subtract 9, becomes the natural log of a negative, positive, very small number. I know what the natural log looks like. It looks something like this. That's your anchor point right there, which is going to be 1, 0. And so what happens is, as x approaches 0, from positive portion, it's going towards negative infinity. My output is going towards negative infinity. 31, I'm just going to give you a little bit of a hint on number 31. It's a little bit tricky, but let's see how 31 works. The limit as x approaches 2 pi from the negative of x times cosecant of x. Well, we know what the cosecant function is. It's the reciprocal function of 1 over, it's a sine or cosine. If you don't know, the s is in the middle here. That's how you remember it. So the s stands for sine. It's a reciprocal for the sine of x. Okay? So if you write this out, that becomes the limit as x approaches 2 pi from the left of x times 1 over sine of x. That becomes, right here, just put it over 1 and multiply straight across, right? Remember, if there's nothing here, x, there's no operation. The basic default operation when there's nothing there means that it's being multiplied. So that becomes x over sine of x, okay? And you can try to figure out what that is. This is going towards 2 pi from the left. 2 pi from the left of sine is going to be close to 0 with from the negative side. Okay? You can graph it if you want, or you can just and see what happens. That's your hand. Let's look at 34. 34, find the VA. 34 is not so bad. Does anybody remember how to find VAs? I taught this to one of my students this last night, actually. These are called rational functions, right? And any type of rational function to find, I'm gonna write this down for you. To find VA, we set denominator equal to 0 and solve for x. It's the same thing every single time. To find vertical asymptote of a rational function, we set the denominator equal to 0 and solve for x. So here it is, number 34. Where's the denominator? It's right over here, right? So we set 3x minus 2x squared, and we set this equal to 0 and solve for x. We know that this is quadratic in nature, so you should be able to know how to solve it. By the way, since there's no constant term, I'm going to factor out an x. What do you get? 3 minus 2x equals 0. If I distribute that in, x times 3 is 3x minus, there it is, x times 2x is 2x squared, right? How do we solve this out? Well, we said each factor equal to 0, remember? So to find VA, x equals 0, that's one of them. 3 minus 2x equals 0, moving the 2x to the right side. 3 equals 2x, and so x equals 3 halves. That's your second VA. It looks something like this. X equals 0 is the y-axis, and x equals 3 halves. Here's 1, here's 2. It will be right here, 1.5. That's another VA. Up there it is. Sorry about that. And there it is right there. There's your x equals 0, or your y-axis. And that's part A. Good luck on your homework, everyone. Hope this helped. And I'll see you for 2.3.